Hello everyone, welcome back to Stat 385 for the second video of the semester. I am on the week 1 page, welcome syllabus. And yeah, I went over this last time in the last video when we covered the syllabus and the web pages for this class. So we'll skip ahead to learning objectives, in particular using prairielearn to complete labs and quizzes. So this would be the this would be the video for lab 00, which if I scroll down to the end, here's where you can find this video. And here on the assignments tab is where assignments would be, and here's lab 00. So again, these are practice assignments. They'll have no effect on the course grade, but they will help you become familiar using prairielearn for both labs and quizzes. I will do a quiz video after this one. Usually we won't do quiz videos. Those would be assignments for you to do. But it will be, of course, standard policy for me to do a video where I go through the lab with the understanding, usually being that you will attempt to do the lab first and then compare and contrast your solutions with mine. Okay, so let's go to prairielearn. So it should just open here. But actually, you know what? That's great. But let me do it from the assignment tab because that'll be more typical procedure. So let's click lab 00. Okay, so prairielearn. Okay, two methods, okay, whatever. Okay, oh, that's right, I'm staff. I will click it to student view. This is what you would see. Oh, this doesn't work. Oh yeah, so I am recording this video before the class has started. So this will load when the class has started. It's not loaded yet. So student view without access restrictions, and this is what you should see. All right, so lab 00, writing R scripts. All right, so this is typically how it will look on prairielearn. There will be lab name, how many points it's worth, and then here, what the questions are. We'll click Hello World. All right, so this is what it typically looks like. So we have, I'm gonna get rid of this. Wait, what's this say? Regenerate yours. Okay, I might just get rid of that. All right, so we have our lab prompt. It is a tradition when learning a new programming language for the first program you write to be the Hello World program. This is a link to the Wikipedia page on Hello World program. Right, so usually a simple computer program that emits or displays to the screen, often the console, a message similar to Hello World. Okay, so this is fairly standard. When you learn a programming language, you figure out how to get it to say Hello World. All right, so, and I'm gonna read these instructions closely. That will be a thing in this class. The instructions are precise. They say exactly what you're supposed to do. You don't want to guess at them. You want to be sure. I've messed it up in the past. I will mess it up again due to thinking that I know exactly what the instructions say, but actually don't. So we need to read them carefully. Okay, so write all requested code in an R script named helloworld.r, and then in the requested file. Okay, let's fire up RStudio. Here we go. I am going to, I'm going to create before I get going, I'm going to create a new project. Actually, let me back up a little bit. On my desktop, I have a file named stat385, lowercase stat 385, no spaces. I don't do spaces. The reason why is because I like to use the command line to navigate files and paths on my computer, and spaces can mess that up. So I do no spaces. I have a file on my desktop. You can see it here. Here's my stat385 folder is going to contain some stuff. If you just create one, yours will be empty, of course. I've taught this class a few times. You can see I have stuff for TA instructions, website, other things. Okay, so one cool thing about R is these R projects. Let me start over. File, new project, existing directory. Browse, we'll go to desktop, stat385, create directory. Okay, oh, sorry. Project working directory, create project. Okay, cool. So now I am inside. Oh, I have a bunch of stuff already open. Right, I've already done this. Okay, so I've now, you can see here that it creates a new R session, and it actually creates it within the directory that I am working in. So now when you open up this document, this R project, you are inside of the correct directory and you can go to work. So what I'll do is I'll create a new folder right away, lab00, and I'll put my contents in lab00. There it is, look, displayed right there. Okay, now just, I'm not gonna do quiz 00 in this video, but I will do it next time, so I might as well just get ahead of the game. Okay, did that work? Wait, did I do that correctly? I thought I did this. Oh, file already exists. Okay, does it take a while to load? Oh, there it is. Okay, all right, so I'm in stat385. Now I'm in lab00. Okay, I'm going to create a new file to work with, and I'm going to hit Command-Shift-N to create a new file. You could do file, new file, and do R script, and you can see here Command-Shift-N, Shift-Command-N. Okay, and now, okay, let's go back to the lab. We've gotten a little bit off track. So write all requested code in an R script named Hello World. Okay, again, do the instructions exactly, don't guess. I'm gonna just copy the name because I want it to be an R script named Hello World. I've created a new file. I'm going to save it as, oops, it's copied the .r twice, and I'm gonna save that in lab00. Okay, so now I have a file named helloworld.r. It's the same name as what is requested in the lab. Okay, so now in the requested file, place the following code. That's it. All right, so do that. For whatever reason, I like to give myself one space. It's just white space. It won't matter as far as like the grading, the auto grader is concerned. Yeah, oh, I should say what the auto grader is gonna do is it's gonna take, let's go to the lab page. So you're gonna upload this file, and then it's going to internally run it in its own R session, and then it's going to compare outputs that you create to output of an ideal case, and that's how the autograder essentially is going to work. It's going to compare what you do to what the correct answer is and work from there. Right, and so when it's running what it does under the hood, it's just working as an active R session. White spaces, lines are just ignored. This is just a comment. Hashtag and then anything is just a comment, and then this is some instructions. What does it do? I'm going to hit Command Return on my Mac, and you can see it. Hey, here's RStudio. Here is this panel for the console, and you can see that's print hello world. And what happened? It printed hello world. Okay, well, I ran it. You didn't have to complete the lab, but I did it. Okay, so now I'm going to save the contents, and hello world.r. Let's go to the lab. Okay, stat385, lab0, hello world, open, save and grade. Okay, queued for grading. This usually takes a minute. Why does this take so long? Sometimes if you go back out and back in, it works. All right, well, while we're waiting, you can see here, save and grade, there's unlimited attempts. For the labs, you get unlimited attempts. It does time out between attempts, but you can plug and play. It's best to be careful and make sure that you do everything correct so that you save time, especially on things which are relatively routine like this. But nonetheless, okay, refresh. Queued for grading. It's taking a while. All right, well, you know what? I'm gonna go, shouldn't take that long. Get rid of this message. I'm gonna go to the next thing. simple function add then power. Okay, so we haven't covered functions in details. This is the first video where I'm going through content, but nonetheless, we will get an inside scoop on what functions are, with a little bit of discussion about what objects are. And that would be more coming on that topic in week 2. Okay, so we have, get rid of that, a simple function add then power. So write all requested code in an R script named add then power. So you gotta be careful. So I'm going to just copy the name, go back to RStudio, Shift Command N. I'm just gonna save it right away. This is actually points. I'm pretty sure this gets you points if you have the right file name. Okay, so I've done nothing, but I at least have a file name that I know works. Okay, write a function named add then power. Let's get the points. So again, this will be new. Okay, add then function. Okay, so it has 3 arguments, A, B, C. They're both numeric vectors of length. They're going to be numbers, right? Essentially what we're going to do is we're going to take the argument that is supplied by the name A, add it to the argument supplied by the name B in parentheses, and then raise that to the argument supplied by the name C's power. A plus B to the C power. Okay, pretty simple. This is just technically what is happening. What these arguments are called a numeric vector of length 1. It's a number, but it's a numeric vector of length 1 in our programming language. Same thing with B and C. Okay. Anyways, the function needs to be 3 arguments. Okay. So A. Let's just try it out. Actually, let's do this. C equals 1, 3, and 2. Okay, so actually we'll get into this more detail, but I'm going to take the object 1, the numeric vector of length 1 called 1, and assign it the name A. You can see as I'm running in RStudio that I've stored these quantities in my global environment, and so if I access A, there it is on the console screen. A is the name given to the object 1 when I assigned it as such. All right, well, A plus B raised to the C. Okay, so if this works, A is 1, B is 3, so that's 4, raised to the squared, raised to the second power, so 4 to the second power is 16. I should get 16. That's what I get. Okay, this is pretty simple, so I'm not going to give it too many test cases. Let's put that in. So now I have function. I haven't given it any. Okay, let's do A, B, C. Okay, so now let's try that out. Okay, so add then power. Let's do, all right, so add then power. So now I have a function, it should take the arguments A, B, and C, whatever I supply here, and then put it into the function body, which is just this, and then run it. And I should just be safe. I'm gonna do return so that it actually, so we know it spits out the right thing. Okay, so now this is my function. There it is. It's in the global environment, and then I run it. Then I get 16. Great. Okay. Cool. All right, so then, what's it say? Oh, what are the instructions? Sorry, I should be reading these closely. Okay. Okay, so write a function named add then power that takes as input 3 arguments. Okay, I did that. It does this. Okay, so in addition to writing the function, add the following lines of code to your file, which will run the function with various inputs and store the results. Okay. Pretty sure the function works. I'm gonna get rid of the test case. Okay, add then power. Save it. Wait, did I not save this in the right spot? Where did this get saved? Is it here? Is it in lab? Ah, good, it's there. Okay, good. All right, so now let's go back to RStudio. Or sorry, prairielearn, my bad. Add then power. Open, save and grade. Grading in progress. Oh, good, I see this. Total points 4 out of 8. That means that I got all the points for Hello World. Let's just check it. Right, oh, cool. So it has a little bit of description here. So I got 4 out of 4, so it checks. The auto grader has some test cases and will award partial credit. So you got 1 point is code free of illegal functions, code, and packages. Yes, that's something that it will check for, and we didn't do anything fancy, so we got all the points. Does code run without errors? We actually ran it. We printed Hello World and it ran, and we know it didn't have any errors. It didn't. Does the code produce expected output? So, first two is did you not do anything illegal? Did it run without errors? So you could have done anything, right? And you would have gotten half credit, and then it checks for did you do the right thing. Cool. All right. Oh, I got all of the points here too. This one, even though it's worth 4 points in total, right? I had 4 points for this question. It checks 7 different things. Again, is the code free of illegal functions, code, and packages? Does code run without errors? So 2 out of 7 there. Do the 3 objects created contain the correct values? Well, I know that I was pretty sure I created my function correctly, and then I copied in this code. So then it's checking whether or not those are the exact values that you should get under correct submission. Okay, and then does the function return the correct output with random inputs? Cool. So what it's doing is it will open up, again, so under the hood, prairielearn will open up its own R environment. This is a function with 3 arguments. So what it's doing is it's going to supply random inputs to those arguments and then check the function, the correct function, against what you write. And if those outputs line up, then we're very sure that you did the right thing. And that's what it does. And that's where most of the points are in this case. Okay, anyways, that is prairielearn. Okay, so let me just go back real quick. Lab 00. So it's 2 questions. This is good practice with engaging with prairielearn, so I recommend that you do it. And we also, as a part of this, set up an R project inside of a stat385 directory on the desktop. I use these conventions, stats, lowercase, 385, no space, and then set up my RStudio project within stat385, and then I can just open this thing. So if I close this project down, close project, and if I'm in just a basic RStudio thing, I can just find it, open up the studio project, and then I'm good to go. Okay, for whatever reason, I have all these things. Okay, I have lab 00, quiz 00, I'm organized, I'm ready to go. All right, well, thank you for watching this video, and I will see you next time for the quiz video. All right, take care, bye.